Okay, this video is going to be solving a system of equations by graphing. Remember, a system is equations, two or more equations with the same variables. Notice at the top of the page here, we have one equation and we have two equations. Okay, they both have x and y. So we're going to solve the system of equations. So what we need to do in this case is we need to make the equations in the form y equals mx plus b. If you notice, the first equation right here is the first equation in slope-intercept form, y equals mx plus b. No, it's not. In order to be in y equals mx plus b, y needs to be by itself. On the left-hand side of the equation, it is not. Okay? The second equation, is the y by itself? No, it's not, because the 3x is on the same side of the equation. So what we have to do is on equation 1, we have to put it in slope-intercept form. So what we're going to do is we're going to start off by putting the first equation in slope-intercept form, which means that this y right here has to be by itself, which means that this 2x and this 3 have to move to the right side of the equation. So just like what we learned in previous units, we're going to take this 2x and we're going to move it to the right side by doing the inverse operation of how it's connected to the y. It's connected with the subtraction sign. So what I'm going to do is I'm going to add 2x to the left side and to the right side of the equation. And when I do that, I'm going to be left with 3y equals 2x plus 21. And again, the reason I put the x first is so that it looks more like this form 2x plus b, or mx plus b. Okay? Is the y by itself yet? No, it's not. What I have to do is I have to divide by 3, because this is connected with the multiplication sign here. The 3's cancel out, and I'm going to be left with y equals, remember this 3 gets divided into both of these numbers on the right side, so it becomes 2/3 x plus 7, because 21 divided by 3 is 7. So now I need to do that same process to the second equation, which is y plus 3x equals -4. So I need to move this 3x to the other side. How is the 3x connected to the y? It's connected with an addition sign. So I'm going to subtract 3x from both sides. And I'm going to get y equals -3x minus 4. And again, I put the 3x first because the slope-intercept form says mx plus b, so I want the x first. Now remember, it's been a couple weeks, so we need to make sure that we don't put the -4 and the -3x together and call it -7x, because remember, like terms, 4 does not have an x, so you cannot put these two numbers together. There's my slope-intercept form. Now I'm ready to graph equation 1 and equation 2. Okay? Equation 1, I need to find the slope. The slope is 2/3, and I need to find the b value, which is 7. On the second equation, I need to find the slope, which is -3, and I need to find the b value, which is -4. So now I'm going to come over here and I'm going to graph the two equations. So I'm going to graph the first equation. I'm going to find the slope, which is, or the y-intercept, which is 7, and then the slope, which is 2/3. So I'm going to go up 1, up 2, right 1, right 2, right 3. Then I can go up 1, up 2, but the graph runs out. So remember, if I wanted to, I can do double negatives, because a negative divided by a negative is a positive. So if I have a negative divided by a negative, I would go down 2 and then left 3. And I could go down 2, left 3, and I would get a line that looks something like this. Okay? Now I'm going to graph the second line. So my y-intercept is -4. So I'm going to go to my y-intercept of -4. 1, 2, 3, 4. So there's my y-intercept of -4. Then my slope is -3. So I'm going to go down 1, down 2, down 3, right 1. Down 1, down 2, down 3, right 1. But remember, I can also go up 1, up 2, up 3, and left 1, because left is a negative movement. So then I go up 1, up 2, up 3, left 1, up 1, up 2, up 3, left 1. And notice how I have 2 points on the same location. And my line's not very good there. But what we're looking for is the point of intersection, which is right there. So what I'm going to do is I'm looking for the solution. So what is the solution? The solution is where the two lines intersect. Well, that's where the red dot is. So they intersect at 1, 2, 3, negative 3. And they intersect at 1, 2, 3, 4, 5 or 4. It looks like 5. And that's the difficulty of graphing, is it sometimes can be difficult to see exactly where they intersect at. That's why we always check to see if they actually work. So that's what I'm going to do down here at the bottom, is I'm going to actually check to see if they work. Okay, so I'm going to check equation number 1. So I can check it in any of the equations. I can check it in the original, or I can check it in the new one. Most of you would probably prefer the original equation because there's no fractions. So that's what I'm going to do. So I'm going to take my original equation and I'm going to substitute my numbers in. So it's the original equation is 3y minus 2x equals 21. So I'm going to substitute my x and y from my solution in. So that becomes 3 times the y value, which is 5. And the reason why it's y value is because it says y, minus 2 times the x value, which is negative 3, equals 21. And if I've done this correctly, okay, then you should get a result of 21. So 3 times 5 is 15. A negative 2 times a negative 3 is a 6, equals 21. 15 plus 6 is 21, equals 21. That one checks out, which is nice. So then I'm going to do the same thing for number 2. And number 2's equation was y plus 3x equals negative 4. So plug the solution in. 5 plus 3, instead of the x, I'm going to replace it with what x is, equals negative 4. So now we do the algebra, order of operations. That becomes 5. 3 times negative 3 is negative 9, equals negative 4. 5 minus 9 is negative 4, equals negative 4. So notice what happens. Both equations are equal when we plug the numbers back in. That means that this is the solution. So when you're solving a system by graphing, you put it in slope-intercept form, which is what we did here. Then you graph and you look for the point of intersection. Once you have the point of intersection, then you need to check to make sure that your answer works.